Hi, this is Murray Campbell, and I'm going to talk about what I did this week for Sprint 3. So, there was a lot of work to do this week, and a few relatively complex systems. So, I'm going to start uh, kind of from the top down and show you how the user uses these systems, um, and then work my way down through the system to show you like what happens when it's called. But first, I'll just take a look at, just show you what I have. Nothing's changed with these managers. Um, I have the new command system implemented with draw, update, alarm. Got this scene registration broker that handles the registration of those commands. Um, I've got my updatable, drawable, and alarm managers that handle their lists and timelines of various, like update calls and like updates and alarms, all of that. And these call their corresponding functions like alarm or update in process elements, that sort of thing. Uh, I have an alarm system implemented that behaves more or less how you would expect it to. We've got 3 alarms. Um, and yeah, all of the corresponding commands. So that's the class diagram there. So let's start by taking a look at um, how the user registers to the various systems such as update and draw and alarm. So in my frigate, I've made the frigate register to the update manager, the draw manager, and 2 different alarms. These are all defined here. I define the alarms, and these get called after this amount of seconds, these amounts of seconds. So in update registration, go here, yeah. We go to updatable.cpp. The updatable has a function called update registration, which goes to it gets the current scene and tells it to update to register this object for update. When we do that, we are creating an update registration command using like the updatable object, and the scene holds an update manager, like an updatable manager object. That just gets referenced there, and then it tells the registration broker to add the command. So let's take a peek at the definition of the update registration command. This is exactly what you think it would be. It has execute. It inherits from command, which basically is just this, but has a virtual void execute. This gets overridden here, and then we've got a pointer to the manager and the updatable, and in the constructor those get populated. And yeah, so in the execute method, do I have a, hang on. So we have the execute method, and then we have the update registration broker, and then in execute, we're telling the manager to register. We're telling the manager to register the updatable to itself, and the manager has all of this good stuff. The manager holds the list of yeah, basically it holds a list of updatables, um, and then it has the register and deregister functions. It checks to see whether or not something's in that list already, and then we have process elements right here, which iterates through that list and tells each updatable to update. So there's that. I'm still working out like clearing the pointers in all of this. That's just something that's always like kind of weird for me. But anyways, we do that. So process elements gets called in scene.cpp. We now have an update method and a draw method for the scene class that gets called alongside the whatever derived class. Actually, no. The derived classes, the derived scenes should not have update and draw methods. The game objects handle telling the scene to register themselves to update and draw themselves, rather than having the scene, tell it to update all of that. So that got taken out. This is really small now. It's really nice. So it just handles the creation and the deletion of these game objects. I don't know if that's the right way to do it, but it feels right now. So update just tells the registration broker to execute commands. We'll look at that in a second. That'll be the last thing I show. It tells the update manager to process the elements, the alarm manager to process the alarms, and then the draw manager to process its elements in the draw. We have all of these functions, which I mentioned before. Take a look at the registration broker now. So that's in scene registration broker. We have just a list of commands in this registration broker. We have a function that adds a command to this list. It just pushes it. And then when we want to execute these commands, it's, the command pattern. It'll iterate through that list of commands and tell each one to execute. That's all well and good. So that functions really well. Nothing wrong with that so far. So now just to talk about alarmable. I showed you only the update manager, like the update stuff, but it works more or less the same for the draw. So there's no need to go in detail with that. We have everything that was required for the alarmable. Not sure what dispatch does, but we'll talk about that tomorrow, I assume. Let's see. Yeah, alarmable has the alarm registration. And this is a little different than the update registration, because the alarmable has to have an array of markers, alarm markers, because there are multiple alarms, and each marker gets assigned to a different alarm. Basically, like, that's not exactly how it works, but that's how I think of it. So we have these. We basically just create a new alarm marker using these alarm IDs that correspond to the functions alarmable, and then we tell the current scene to register the alarm. Actually, I should start. Let me explain alarm marker, and then I'll start from the top on like the user side. So here's the meat and potatoes kind of bit of this. This is the alarm marker. It has a trigger time, which I made public. It might be a bad idea to do that, but who knows? And then a call event, which basically calls the corresponding alarm method, and I do that in an if this sort of structure. I could have chosen a switch statement, but I think for my purposes this is a little faster. I don't know if this is completely off the mark. There's another quicker way of doing this, but this is what I do. It calls the functions. That's all well and good. I know I'm running a little high on time, but bear with me. This is a lot of stuff to go through. So basically, the user will register for each alarm that they want. They just specify the ID. They can only use one at a time. That's not enforced, but yeah, I don't know. Anyways, and then they specify an amount of time they want for that. I'm just doing this in the constructor. It can be done elsewhere, I assume. And we define the functions. That's all good. And then we deregister when it gets destroyed. But let's take a look. We'll go to the definition of alarm registration, and that's what I just showed here. So it tells the current scene to register this alarm. So we create the command for it, and then we tell the broker to add the command. The alarm registration command has the same sort of thing. It's got a pointer to the manager and a pointer to the marker, and that marker just gets passed through. Then when it's executed, it just tells the manager, the alarm manager, to register that marker. So in the manager, the register function just register, assigns it to this timeline. It takes the timeline is a map. Right now the map is an alarm marker to float for the time. That might change, but I pull the trigger time from the marker for that float value, and then in process alarms, this is where everything happens. It iterates through that timeline, and if the total time, the time in seconds since startup, is greater than or equal to that float value for that marker, it will call the event on that marker, and that will in turn call the corresponding alarm. That's how that works. That's pretty much it for this sprint. I'm just gonna show you that my game is working. And there we go. Works all nice. Oh yeah, you could have seen in the bottom of the output window there, like a little debug message come out. So my alarm system is working. But yeah, that's it. Thanks very much for watching. I know it was 13 minutes, God, but that's what it takes, you know?